So plans A through C were restricting one of the three conditions for a data race. But of course, we can get a little bit more focused than that, or a little bit broader than that, by having sort of combinations of restrictions or more specific restrictions on those conditions. We just talked about Erlang Elixir, and really the way to think about that is possibly that we're restricting mutability and shared data. And that just makes absolutely sure that we won't have that class of data races at least, and gives us some flexibility in having internal optimizations in the system that potentially make little exceptions to, in this case, whether or not data is really shared. It doesn't look to the user like it's shared. Another example of a combination is when we restrict mutability of shared data. So it turns out that only shared data is a problem to mutate. If we have unshared data, we can mutate it fine. And if we have shared data that is immutable, that's fine. So all we need to do is restrict the mutability of shared data, and we've solved the problem. So I have an example here in Rust where we're going to do the Sum 101 example. We start with 1,000 million billion. We're going to have 10 threads. Each thread is going to do 1/10 of the numbers. We'll start with a sum accumulator of 0. We will spawn 10 threads. Each thread is going to calculate which numbers it's responsible for looking at. And then every number that is divisible by 101 will add into that shared sum. We'll then join all our child worker threads and then print out the resulting sum. You can see some squiggly lines here. This isn't going to work. And when I go ahead and run this Rust code, or try to run this Rust code, it doesn't even compile. And the error that it gives us is we cannot borrow sum as mutable more than once at a time. So we have this variable sum, which is referring to a mutable 64-bit integer. And in this anonymous function that we have here, that's what's going on here, is this thread spawn method, I guess, function. Thread spawn function takes an anonymous function as an argument, like lambda as an argument. And when we have lexical capture of that sum variable, and we try to reference it in here, Rust realizes that this reference to it in here has to also be mutable, but it knows that we're calling thread spawn here more than once, and this code may execute concurrently. And therefore, it cannot allow us to have this, this sum variable here in the anonymous function be a mutable reference. We can't have more than one mutable reference to a variable. That's how we enforce that shared data can't be mutable. And so it just categorically disallows this. So in order to solve this problem, what we have to do is not mutate shared data. And in Rust, that's pretty simple. You can see the pieces here commented out. To make this work, I have to make this a move closure. I have to have a local sum in each thread. I don't want to declare my external sum until after the threads have run. And I want each thread to return the local sum, so I can add that into the global sum. And now we're to the optimized version that we saw in C, where each thread is going to calculate a local sum variable, and then at the end, each thread returns its local sum. The main thread adds it up in 10 steps because there's only 10 child threads, and we'll get our result. So we'll run that, and it's a little slow. I'm going to blame the development build in Rust rather than anything else here, but we get the answer that we expect, and Rust just didn't allow us to write the code that would have the data race. So that's that example.